Okay, so members, in today's lesson, we are going to see how do we handle locus when they are giving us the distance from a point. Now recall, if we have a distance from a point A, x1, y1, from a line, the first line is this distance d is equal to always A, we replace with the x of this with the x coordinate of the point, then the y coordinate of the point, then plus this over the square root of these coefficients of x and y. So all they are telling us in this question, find the locus of a point which moves such that its distance from a point this is equal to its distance from a fixed line x equal to 2. Now what we do first arrange this into this form, meaning that we first create a 0. So now this our line is going to be x, now capital X minus 3 equaling to 0. So that's our line. So I think that's that the distance d from this to that point, I think that's that which moves so that its distance from a point A, it means that now if our point is, let our point be P of that. So this P A, its distance from that, is equal to its distance from a fixed line. Its distance from a fixed line, let us call it D. So now to get this D, so that our D from there, let us first get our D. Our D will be now modulus of, now where there is x, we put, you start just substitute these points in here. So it means that now this x is going to be now my small x minus, so now our this side is negative 3, the whole over square root of 1 squared plus 0 squared. It's that y is there, but the coordinate of y is, the coefficient of y is 0, and this will be now modulus of x minus 3, which will be x minus 3. Now, here, there is a discussion. Some people, because that we are assuming that the modulus should be positive, now me I'm assuming that the value of x that is going to work there is going to greater or equal to 4, so that all we get is positive. So from here, so our distance is equal to x minus 3, but I've put a condition on the value of x. So now we get our PA, so that our PA is equal to D. Can we get D? PA. From there, our PA from this point to be now, the distance between this point to be now the square root of P. Its coordinate is x minus this, which will be x minus now 3 squared and plus the y minus the y of this equaling to b, but my b is x minus 3. So remove this, we square both sides. And we have now and expand, we have x squared plus 6x plus 9 and plus y squared equaling to x minus 3 squared. If I square this, the square root goes away, I expand this, and this is this, then I square the side. So this would be equaling to x squared minus 6x plus 9. So you see that this will cancel with that. You see that when I have a bear, when I take this inside, that also 9 is going to cancel. So I have y squared equaling to, when I take this inside, I have negative 12x. And remember that this one is a parabola. You can get its vertex. So its vertex you can get if you compare with the general x squared equaling to 4ax. So now our 4a we compare, so it's negative 4. So that my a is going to be negative 3. So it's that the locus we get is a parabola with the vertex. We can put the vertex there and then the directrix and so on. So you can stop there, or you can go on to describe the negative 3, 0, as simple as that. I wish you the best.